Hello, Dalal. Is there... I can start helping you if you like. All right, Dalal. Is there somewhere you wanted me to start with you? Like either from the worksheets or the textbook? I can work through those as well. Hey, Mina. To see... Oh, from... Sure. This toy rocket one? Sure. I'll just kind of work through the whole thing here. So, let's write this down. Okay, so for this question here, we've got a toy rocket is launched vertically upwards. They give you the equation, and its height to the ground is measured by the following equation. Part you wanted to C, but let me just go through A and B as well. They ask for how long will it take for the rocket to return to the ground. The first thing to notice here is if you take a look at our equation, I can simplify this a bit. 128 is divisible by 16, so I can factor out a 16t here, and you're going to get t minus 8. So this will actually factor for us as follows here. Into negative 16t minus 8. So they want to know when will the ball hit the ground. Well, when the ball hits the ground, you're going to set h equal to 0. And that means you're going to get two values. So in which case t is 0 or t is 8. So I know you already have this still, but the answer for this one is 8 seconds. If you go to graph this, it'll look something like this. And we know it's starting at 0 and it's going to 8 seconds. Okay, in part B here, so that was A. If you take a look at part B, it asks after how many seconds will the rocket be 112 feet above ground? So now you're asking, you're setting the height equal to 112, and you want to solve this equation. Right, notice I didn't set it equal to my factored quadratic because I would have had to have expanded it out anyways, so I just went right ahead and set it equal to my original quadratic they gave us. And I want to solve this, so I have to bring everything to one side. And then you want to look to see whether you can simplify. I can actually divide across by negative 16 again. So I'm going to get here 0 equals what? T squared. Minus 8t. And then this will end up being 7. So I end up getting t squared minus 8t plus 7. So this factors nicely into t minus 7 and t minus 1. So you end up getting two values here as 1 and 7. So if you go back to our diagram, they want to know when is this question, when is this, how many seconds will the rocket be at 112 feet and above. So it's kind of like a line here, like we've been doing. This is 112. And I ended up getting two values. That's when t is 1 and when t is 7. So I think they left this as the answers, just t is 1 and 7. But like we discussed, you have to subtract these two, and the answer is 6 seconds. So the rocket is at or above 112 feet for 6 seconds. Okay, so there's A and B. And now let's take a look at C here. This is a question Dalal was getting at. How long will it take for the rocket to hit its maximum height? Well, you know what? We already have the roots. I know the roots here. I mean, there's a bunch of things we can do here, but what you could do is you can take the two roots, add them up, divide by 2, you'll get your middle. Right? So one way I can do it is how long will it take for the rocket to hit max height? If you add up your roots and divide by 2, you're going to get 4 seconds. So going back to this diagram here, right in the middle is my axis of symmetry, which is t equals 4. So I know max height happens at your vertex. So because max height happens at the vertex, we now have that after 4 seconds, the rocket will hit its max height. Notice I could have also done this to the t values here. There's nothing really unique about the roots, adding them up and dividing by 2 to get the 4. I could have also added up these values here and divided by 2. I would also get the 4 because both of these have the same y coordinates. That's what allowed me to do this. Like this point is 0, 0, and this point is 8, 0. So these had the same y coordinate, which in this case was 0. And for this point here, this point is 1 and 112. And this point here is 7 and 112. And you end up getting the same y coordinate here, same y coordinate here. So again, you can add them up, divide by 2, you get the same thing. Okay, so there's 2C, Dalal, since you're asking. And then in part D, they ask for the max height. Just sub it in. You don't have to, I'm not going to ask you to sketch the diagrams, but I just don't know how you'd answer some of the questions unless you can sketch some of the things that are going on. But no, I'm not going to like explicitly ask you to sketch the diagrams. For part D here, it asks you for the max height. That's just a matter of subbing it in. So my H value here, it is negative 16 4 squared plus 128 times 4. And if you calculate that, I'm getting 256. All right, so there's number 2, those of you who are asking it. I don't have any other problems I can think of. I've kind of assigned if you got through all of those, I think you should be fine for the motion questions because I think about a dozen different ones have been assigned. There's not many more variations on that. But I can try to think of one if you're just looking to work through it. Are there any other problems I can work through here? All right, Matthew is asking for some examples here. Another one, what you could find with this one, if this is a motion of an object again being hit, you could find, if you are looking for some more to work on, and I can take this up, you could find the initial height of this expression. And then part B, when does it hit the ground? And in part C, you could discover how long is it above 10 meters. Oh, sorry. Try not to cover up my, let's see here. You can try this one out here. This was 32. I'll recover this up here. Okay, yeah, you can try these out. Anything else I can go through here? We can do number 4 if you want. Together we can take a look at 4. So for 4 here, they want the max height of the grappling hook. Sure. Fencing 1. Okay, that would be in the other worksheet, correct? Yes. If you didn't get those copied, Matthew, here's the questions I had written down. But yeah, let's take a look at fencing 1. Is there a specific fencing 1 you want me to go through, or are we good? Okay, good. Okay, let's take a look here. So we'll do a bunch of these. So in this question here, you've got 32 meters of fencing to work with, and you want to maximize the area. So they tell you in the question that one of the sides we do not need. We're going to be putting this fencing against a barn. So right away, you know that you sort of have this layout for this fencing question, right? X, and Y, right? These are going to be the same length, and this is going to be a different length. So with a question like this, I'm looking to maximize the area. So the area of a rectangle is X times Y. But like we were saying here, you can't maximize 2 variables. You can only maximize 1. So what I do know is that the perimeter, the amount of fencing I have to use, which is 32, is going to equal 2x plus y. So because of that, I know therefore that y is going to equal 32 minus 2x. So I know that y equals 32 minus 2x. So therefore I can get rid of the x and I can change it to a 32 minus 2x, right? But now I have a quadratic, and I have a quadratic that opens downwards because, right, that leading coefficient is negative if I were to open that up. So when is, like on my axis, my y-axis here is area. This is going to represent area. So when is the area going to be 0? You can set this equal to 0. And we got 2 situations here. Either x is 0 or 32 minus 2x is 0, in which case x is 16. So for a question like this, you actually have 2 spots, 0 and 16. These are like the extremes to the question that result in an area of 0, but I don't want that. I want the max area, which happens at the vertex, right? Because this is a quadratic, because this is in fact a quadratic, the max is going to happen at the vertex. So that's going to happen exactly at 0 plus 16 divided by 2, which is 8. So when x equals 8, I end up getting my max area. But therefore, if x equals 8, then y is 32 minus 2 times 8, which is 16. So it turns out that to get max area for this question, the sides have to be 8 apiece, and this is going to equal 16. Right, so those are the dimensions that give max area, and for this question, the actual max area is going to equal 8 times 16. Will give you the actual max area, and if you multiply that out, you get 128 square meters for this one. Right, so that's example 5, or this example 5 here, the fencing one, but we can take a look at a couple others examples of these fencing questions. Here's like does anyone still need to copy this? We're okay? I can look at more examples, like example 6. It's a little bit of a difference. This time we have 600 meters of fencing, and you're creating like a double enclosure, like two rectangles kind of stuck together. So if you're doing that, you can label this as X, this is X, this is X, and these top values as Y. So this is going to be Y and Y. Right, so you'd label that differently. So this will be area is still X times Y, right? That'll still be right? Because if I take my X multiplied by my Y, that'll give me the total area of this shape, this whole thing, right? So that's what I want. But I can't maximize that, but I do know that the 600 meters of fencing is going to equal 3x plus 2y. So it's a little bit different here. The math is a little bit rougher because you don't have an individual variable to isolate for. Like in the previous one, I could isolate for y and get y by itself nicely. I didn't have to isolate for x. But here I have to deal with fractions. So I'm going to isolate for y again, but you can isolate for x just the same. But this time we have to deal with fractions. So I'm going to go ahead and divide across by 2, which is going to give me 300 minus 3/2 x. So now, again, I have a little more math to do here because I do have these fractions. So I can get rid of the y, and I can change it to a 300 minus 3/2 x. Right? So same idea, I have a quadratic. Quadratic opens downwards, right? And then again, I can find my roots. So I set my area equal to 0. And I'm going to solve for each of these. Well, one's easy. X is 0. Works out nice. The next one is 300 minus 3/2 x is 0. So I can subtract 300 on both sides. Then I can multiply across by 2. And then divide by -3. So I end up getting 200 here for the other root. Are you guys able to follow that? For sure. Is this okay? Okay. So now that you got these right in the middle, which is your axis of symmetry like we've been doing, you're going to get 100 right in the middle. So that means that when x is 100, we have max area. So therefore, x equals 100, and in which case y is going to equal 300 minus 3/2 times 100. And everywhere I see, I'm going to reduce this. Now again, we've kind of talked about this before. If I want to evaluate this, this is really over 1, and you can just divide this out. 100 divided by 2 is just 50. So this is 3 over 1 times 50, like if you do your math on that. So you end up getting here y is 300 minus 150 is 150 for this. Yep. So we've got 100, x is 100 and y is 150. So these have to be 100, each side of these have to be 100. And 100. And 100. And the top and bottom are 150 each. If you do that, you will find max area. What is the max area? The max area is just your x times your y, right? Which gives you your 15,000 square meters. So this one involves fractions, so it's a bit more work. All right, any questions with example 6? Okay. All right, this one here, I had asked this one. I can take a break from fencing questions and I come back to this fencing one as well, example 7. But I'll just add a page here. Let's just tackle this one. Since there are some answers, we can check them out. So I just made this one up. I don't think the numbers will be that friendly, but the initial height for part A, if I were to answer this, the initial height, you're going to let t be 0. So you're going to have to calculate negative 4.9, 0 minus 1.5 squared plus 32. So I'm getting for the initial height, and you can kind of let me know if you got different, in case I did make a mistake calculating. I'm getting 20.98, and I didn't say what this is in, but we can assume meters, it's fine. I'm getting that's the initial height, so it's kind of like going like this. I've got leaving from some cliff, whatever it may be, at 20.98 meters. This example here. So that's part A. Does that check out? So then it asks in part B, thank you, it asks in part B, when does it hit the ground? Okay, so when it hits the ground, you're going to set your height equal to 0. And if I set my height equal to 0 here, and I go to solve this, I don't want to have to expand this out, put it in quadratic form, standard form I should say, and then use the quadratic equation. You want to solve it quicker, and the quicker method is to bring the 32 to the other side. Then to divide across by negative 4.9. So if I go ahead and do that, I get what 6.53 is approximately equal to t minus 1.5 squared. So then you can take your square root and then add 1.5 to each side. I'll have to get this down to like some numbers here. You're not going to leave your answer like this, but I'm getting here. I'm getting t is approximately 4.06. And then $1.44 roughly. Is that right? Should it be? There's a mistake there for sure. Let me check my math on this. Oh, sorry. I got this one's wrong. Just made a calculation mistake. That should be negative 1.06. And again, as a reminder, I knew there was a mistake right away because of the diagram. So back to Maria's question, you don't have to graph on the test, but it does help out quite a lot. Like I knew the other value, if I extend this, should have been negative because time is 0 right here. So I was expecting a negative value. I didn't get it. So, the diagram is helpful, but I do know that this hits the ground when time is approximately 4.06 seconds. We hit the ground. Good. All right, so that's when it hits the ground. And then lastly, I ask how long is it above 10 meters? And the same sort of idea, how long is this above 10 meters? Go ahead for part C, you're going to set your quadratic equal to 10. And you're going to solve this. But again, you don't have to expand this all out and do the quadratic equation. If I'm going to solve this here, I can bring the 32 to the other side. So you're going to end up with minus 22. Right, and then you're going to go ahead and divide this out. So negative 22 divided by negative 4.9. I get 4.49 is approximately equal to t minus 1.5 squared. You can go ahead and take your square root here as 4.49 and solve for t just the same. So I get t is approximately 1.5 plus or minus the root of 4.49. And this will generate two answers again here. One answer I'm getting is 3.62 seconds. And 1.5 minus the square root. The other answer is negative 0.62 seconds. So I got these two times here. Now, what does that mean? The reason we got a negative time, too easy, I know, good. The reason we got a negative time is because the ball, like the rocket, whatever I'm shooting here, this question, we were already 20.98 meters above the ground. So the question was asking, well, how long are you above 10 meters? Well, 10 meters is maybe somewhere here. Like this is like your 10 meter line, right? H is 10. So when time is 0, which is when the question starts, and this is why the diagram is helpful again, is I'm above 10 meters here, all the way until I hit this spot right here. And then I stop. So because the length that you were being asked was below your starting point, I was already above 10 meters when the rocket left the ground. The object left the ground. So this is inadmissible. I don't need this. And the answer here for this question is just 3.62. So we didn't have to subtract. Whereas in previous questions, we had to subtract. We did not have to subtract in this one. And that's where the diagram does come in handy, because you can reference the diagram to what you anticipate, right? Like if the question said 10, I already know I'm going to get two different answers. Even if the question said 20.96, I would still get two different answers, two answers, but only one I'm going to use because it's below, right? But as soon as that answer, if you take this exact same question and you change the 10 to like a 22, now you're going to have to subtract your answers because you're going to end up getting like a line here, and that's going to generate two positive time values, in which case then you have to subtract. So just kind of making you aware of the differences with these. All right, so there's just a question I had made up just to try it out. I can go ahead and finish off with these fencing questions. I don't know if there's, actually we can do 8. Yeah, if both numbers are positive, then you're going to end up having to subtract, Marie. That's true. Yeah, like if you're working with messy decimal places, just keep two decimal places. Your answer will be slightly off, but it won't be that off. Like even notice, yeah, it should be fine. I wouldn't. These are all rounded answers, but they still work out. Like notice these two roots I found here. If I add these up and divide by 2, I still get my axis of symmetry of 1.5. Same with these two values. I add these up and divide by 2, I still get my axis of symmetry of 1.5. So if you carry two decimal places, you'll should be good. Okay. I don't know if this 7 is anything difficult. Okay, no, this is 7's a standard one. That'll just be a square. We can take a look at 8 if you want to do another fencing one. This is 240 meters of fencing, and it's looking like this. So the diagram is fairly different. So with this one, the area is length times width. But I want to... How many questions on the test? Well, there's greater than 0 questions on the test. Less than 4. So with this one here, we're looking to solve this here. Yeah, the test like we had talked about, I already had mentioned this in class, so I can tell you guys now. It doesn't make a difference. But yeah, let's go. Yes, let's go. Let's go. That's good. So you're happy that there's 3 questions. First question is a motion question in standard form. Second question is a motion question in vertex form. And the last question is a fencing question. Who knows how many fences, though, Dalal? We don't know. Let's go. So with this one here, again, the perimeter, the amount of fencing you have to work with is 240. We've got WWWW, that's 4 W's and then an L. You're leaning this up against a barn here, so a little bit different. You can pick a variable to isolate for. You can isolate for the L or the W, but obviously isolating for the L is way easier. So I would go ahead and isolate for the L and then dump that into your equation. So I can get rid of, actually I'm going to move it down here. Oops. I can get rid of area here. The L, I can change it to a 240 minus 4W times W. And now we're solving this. So you're going to set your area equal to 0. And just like we've been doing, this is going to be a quadratic that opens downwards, right? I know one root is 0, and this root here is just going to be equal to 60. 60. So if you cut this down the middle, you know the middle is just, you average it out, which is 30. Right, so for this one here, W is 30. So when this is the line W equals 30. So when W equals 30, you're going to get max area. Well, if W equals 30, then L is going to be 240 minus 4 times 30. L is going to be 120. So I know L is 120 and W is 30. So this is 120 and these are 30 apiece. 30, 30, 30, 30. Oh, sorry. Keep doing that. I got 60 because I took the 240 minus 4W and I set equal to 0. So if you actually solve this, yeah, 60 is the second root. One of the roots is 0 and the other root is 60. I kind of looked at it and saw that 60 worked, but I didn't like formally solve for it. But that's how you would solve for it. You get W equals 60. So I've got here my two roots. You average out, you get your middle, and we're good. Is this okay? That's about as complicated as the fencing questions can get. I mean, I guess I can add a fourth fence. You know, you can have 4 boxes, 5 boxes, but I mean, that's about it. I don't know if you guys noticed, but there's obviously a pattern with this. Like, if you look at the 2 fences, 3 fences, 4 fences, it does make a pattern, but solving it is just as easy. Oh, how did I get the 30, but did you just add? Yes, yep, I average it out. So that's where the 30 came from. Because I got roots of 0 and 60, you know the middle is your axis of symmetry, so 0 plus 60 right over here. 0 plus 60 divided by 2 is your 30, gives you your middle. Okay, so there's that one. So there's the fencing questions. Did you want to go back with the quadratic motion questions? Does anyone need help with those ones? They'd like me to go through those? All right. Any other questions? Are we good? I don't know if there's anything with the motion questions. Yes. I'll run through a couple of these just in case there's any issues tomorrow. Okay, so this is one of the word problems. Unless there's questions from the textbook people want me to take up, I can run through some of these, and then if everyone's good, we can stop. But for this one here, you've got, this is a hiking question. They give you a quadratic. negative 16t squared plus 32t plus 5. What is the maximum height? So again, just remember this. I think you guys got it by now, but right away we know this quadratic does is about 5 meters from the ground. Is it 5 meters from the ground? You can see the when time is 0, this starts off 5 meters from ground. The question's asking the max height. Well, you know that's going to equal negative b over 2a. So in this case, negative 32 over 2 times negative 16 is 1. So therefore, when time is 1, that's when max height happens. To find the actual max height, you just let t be 1 and sub it in. So we can sub this in. And in which case here I get negative 16 plus 32 plus 5. I'm getting here 21. So this vertex here is 1 and 21. If there's any one thing with this here. So the max height for this one was 1 and 21. Can you throw it high enough to reach the ledge? So this ledge question is below. So the answer is yes, obviously, because the ledge that they're speaking of is at the 20-foot mark. So then we're okay because you can actually get it up to 21 feet. So it should be fine for number 4. Okay, are there any other questions or are we good and we can stop? It's up to you guys. All right, perfect. Okay, so I'll cap it here. I think everyone's got all their questions answered that they wanted. I'll stop it here. Good, good, good. I'll stop it here. You can review these questions if you want. This will be posted for you, and then we will, no problem, Marie. We'll have our quiz tomorrow. Okay, guys, I will see you tomorrow. Thank you. See you, Kinlan. See you, Amina. No problem. Good night.